Hello everyone, I am Anshika and today we'll be starting this series of doing DSA questions on this channel. So, we are starting today's uh, video with the topic of searching in arrays. So, I'll complete this topic in two videos, that is for linear search and binary search. This video is all about linear search and how we can solve this problem by using basic algorithm and logic. I am proficient in C++, so I'll be looking at this problem through that lens. But as we all know that logic and algorithm remain same throughout all the programming languages, so it's not necessary for you to only look at the problem in one language, but you can also do it in your language, in whichever language you prefer. So basically, we'll start this video by understanding the problem in detail and what the question really asks for. After that, we'll be going towards the brute force and basic logic in solving this problem. Then we'll be also looking at the time and space complexities of the solution that we derive at the end of the video. After that, we'll be continuing binary search in the next video. So let's begin. So for example, we have an array that is given to us with the elements 1 to 6. As we all know that array is a continuous memory linear data structure. So obviously this array begins with the index 0 and goes up to index 5. Now we have to search for the target that is given to us, for example 5, in the given array, and we have to return the value of index at which the element is present. And if it is not in the array, then we are supposed to return -1. Now for this process, we just know, like if you can really think about it, that we are given a set of elements and we have to look for a particular element. So we go one by one, look for each element in that place, and if it is found, then we just count the number that it is over there, and then we return that number, that at which index that particular element is present. So that's the same thing that we are going to do here. We'll just put start, for example, we'll just put a for loop that will go start from index 0 and go till the end of the array. We will look if each element is present in that place for each index, that is 0, 1, 2, 3, 4 and 5. If it is present, then we will return the same index value, and if not, then we will return -1. So for that matter, let's begin writing the pseudocode of this problem. So let's start by making a function that is linear search. The return type of this function is going to be integer because we are only returning either the index or the value -1. Then we'll just also pass the parameters that we'll be using. So obviously we have to include the array that is of integer type. Then we are also going to include the size, that is going to be n of the array. Then we'll be including the target, that is we have to find. In this function, first we start with our for loop. We begin from the index I is equals to 0 and we do this until we get to the end of the array, that is I less than n, and for each index we further increment the value of I so that it reaches the end. Now in this for loop, we have to check whether the element is equal to the target that is given to us. So we are first going to check using a if condition that the target element is equal to the element that we are on currently. So if the element at ith place in the array is equals to the target, then we have to return the index, that is I in this case. If not, then we are supposed to return the -1. Okay, so this is basically the whole pseudocode that we are supposed to write. Now after this, let's understand it better with the help of an example. So over here, let me take an array of a few elements. Suppose 20, 25, 18, 30, 15, 7 and 9. Over here, first of all, this is our index 0, 1, 2, 3, 4, 5 and 6. The size of this array is going to be 7. Now we begin with I is equals to 0. Okay, now since 0 is less than 7, we check our condition and we move to the if statement. If the array of I, now let's also keep a target, let's let it be 7. Okay, so the target that we're looking for is 7. Over here, if the element that we are on currently, that is I is equals to 0, is 20 equal to 7, it's not. So we move to the next place, that is I is equals to 1. Is 25 equal to 7? It's not. So we move to the next place, that is at index 2, 18. Is 18 equal to 7? No, it's not. Then we move to I is equals to 3. This is 2. Still nothing found. Then we go to 15. That is I equals to 4. Still nothing. Then we go to I equals to 5. Over here we have found 7. And that is equal to our target, that is 7. So we will return 5. That is the index at which 7 is present. Now, for example, if our target would have been 10. So since 10 is not in this whole array that is given, it would have returned -1 in this case, because the array would we would have traversed the whole array till n is equals to till less than n is equals n7, and that is why we wouldn't have gotten anything and we would have returned -1 from this function. Now after this, now that we know that if the element is found, we are to return the value at which it is placed, and if it is not, then we are to return -1. So after this, we can see that the time and the space complexity of this whole solution is going to be big O of n, that is time, and big O of 1 for the space complexity. Now this time complexity is big O of n because in the worst case that we can have is that we can traverse the whole array and still we can't find any element. So in that case also we have to traverse the whole array till the nth place. So that is why it is going to be linear or big O of n in the worst case scenario, if the element is either present at the last position or it is not present anywhere, still we have to traverse the whole array, that is n times. And the space complexity is going to be big O of 1 because we are only returning a specific value, that is either we return index or we return -1 from the function. So there is no other space that we are using in the solution, so that is why it's going to be big O of 1. Now after all of this, I would like to show you the code the actual C++ code that we can get that has the function and also the main function that will help you understand it more clearly. So this is the C++ code. Over here we have under the C++ boilerplate code that we have mentioned a function called linear search. Okay, now this linear search function is, as we've mentioned, it has the array n and the target. Then we have used a for loop, as you can see, from 0 to n and I plus plus, then array I is equals to target, and then we've returned -1, and if we can't find the element, then at the end of the for loop we've given return -1. And in the main function we have initialized our array to the elements that are given, and we have then calculated the size of the array, that is n, using this formula. Now we have called the linear search function and stored the value that it will return in a variable, that is ans, answer. Then we have used the cout function to actually print the value of the answer that is returned from the function. And then we have written return 0 so that we can actually end the main function. So this is the example. After this we have also the same code in Python, so that for all of you who are doing their coding in Python can also look at the solution over here itself. As you can see, this is the syntax that we have used and the output, that is 4 for this question, as we have seen that the element is placed at the 4th index that we are looking for. So this was all for this video. In the next video we'll be covering up the binary search. Thank you.